In this ACT math video, we're going to take a look at geometric series. And this is the problem we're going to take a look at today. So a grasshopper is making jumps on a lawn. On the first jump, it covers 20 inches. For every jump that follows, it jumps exactly half of the distance of the previous jump. How far in inches has the grasshopper traveled after 25 jumps? And so at this point, you can stop the video and try to solve the problem on your own. Or you can keep going and we'll get into solving the problem. So a sequence is just a pattern of numbers. And when you're multiplying by the same amount each time, we call it a geometric sequence. The number that you're multiplying by each time, we call the common ratio. So if you see below, we have two different sequences. You've got one sequence where you're multiplying by 5 each time, so the common ratio is 5. Now notice in the second sequence, you're dividing by 3. Any sequence that's a dividing pattern can always be written as a multiplication pattern by a fraction. So in this case, dividing by 3 is the same thing as multiplying by 1/3, so the common ratio is 1/3. Now, when you take a sequence of numbers, a pattern of numbers, and you add those numbers up, we call it a series. So what we're going to tackle and focus on today is geometric series, taking a multiplication pattern and adding the terms up and predicting where the sum will be. So what you're looking at right now is an overview of the grasshopper's behavior. So for every jump that follows, it jumps exactly half of the distance of the previous jump. So you can see that it's going from 20 to 10 to 5, etc. So it's dividing by 2. But once again, when you're dealing with a division sequence, you can re-express it as a multiplication sequence by a fraction. So dividing by 2 is the same thing as multiplying by 1/2. So we have a geometric sequence where the common ratio is 1/2 or 0.5. So we need to know the total distance in inches that the grasshopper has traveled after 25 jumps. And so there's two different ways to attack this problem. The first way is to get a couple of terms of the pattern, get a couple of the sums, and then predict what the total distance will be. The second way is to employ an actual formula to figure out what the sum of this geometric series will be. Keep in mind, this is a series because now we're adding up the terms of this multiplication sequence. So let's go ahead and do this the first way. I'm going to write out a couple of terms of this pattern. So we've got 20, and then 10, and then 5. Taking half of 5 gives you 2.5. Taking half of 2.5 is 1.25. And half of 1.25 is 0.625. And it goes so on. Now let's go ahead and get a couple of these sums. So first what I'm going to do is add up the first 4 terms. Adding up the first 4 terms, you're going to end up with 37.5. Now I'm going to take that sum and add the next term to it. So plus 5. Like I said, you won't have to write this over and over again if you have a calculator. So I'm just doing it just for the video. And so adding 1.25 to that sum, you're going to end up with 38.75. Now we're going to add that next term to it. And the next term was what, 0.625. And that gives us a total of 39.375. So you can see that the total distances as we keep going with the jumps, you're starting to slow down and it looks like it's approaching 40. So my guess is that the total of these jumps is going to be about 40 inches. And believe it or not, that is the correct answer. So the answer is 40 and the answer is D. Now let's look at the second way to solve this problem. So we need to go ahead and add up the first 25 terms of this series. Now, if you've tried using a calculator with this, you'll start to instantly realize that finding all 25 terms and adding them up is not easy, and it's going to waste you a lot of time. But fortunately, we can use a formula that'll help us find the sum of the series. And people who have already taken pre-calculus will probably already be familiar with this formula. And so to find the sum of a geometric series, it is equal to a of 1 times 1 minus r to the n over 1 minus r, where a of 1 is the first term of your series, r is the common ratio, or what you're multiplying by each time, and n is the number of terms that you're adding up in this pattern. So the first term of the series is 20, so I know that a of 1 is going to be 20. I know that for our series, or for the pattern, it's multiplying by 1/2 each time. So the common ratio is 1/2. And since we have to do 25 jumps or 25 terms, n is 25. Now we can get the exact sum. So plugging into the formula, you're going to end up with 20 times 1 minus, and the 1/2 is raised to the 25th power, all over 1 minus 1/2. And so if you work this out in your calculator, you're going to end up with an answer of 40. So the total distance that the grasshopper has jumped is exactly 40 inches. And once again, the answer is D. So go ahead and visit mathonthefly.com, where we have over 100 ACT math worksheets that cover a variety of topics. And while you're at it, go ahead and join the mailing list so you can get updates on what's going on. And we also offer an ACT math book where we have over 1,100 problems with complete solutions, and it's a perfect guide for the test. And with that being said, I hope you liked the video, and I'll see you in the next video.